Assalamu alaikum. How are you, my friends? This is the video number 5, which talk about the temperature devices. Okay, now one of the technology used to create a device that measure the temperature is the change in the junction of different material, the change in the voltage between two different material if they are connected in one junction. This device is known by the famous name thermocouple. Couple mean two things connected together, and thermo because of the effect of the temperature. And another device generated by using this thermocouple is called thermopile. So if we have a different material exposed to the same source, heat source, they will generate a difference in the voltage. Of course, when I say difference in the voltage, it's normally very small values in micron. Okay, before going to the videos that talking about the thermocouples and thermopiles, let us just talk about the theories, which is the basics for building this device. Three theories. We call it effects, the three effects principles. They saying is what? The first principle saying that Seebeck effect is called Seebeck effect is saying that the voltage produced in a thermocouple is proportional to the temperature between the two junctions. So if there is a temperature between two junctions, there is a voltage will be produced. Pelter effect. Pelter effect is saying that if a current flow through the thermocouple, one junction is heated, the other junction is cold. That means if you have a current, that means there is one of the junction is cold and the other is heated. So we need two junction here, one cold and one hot. Thomson effect saying that when the current flow in a conductor along which there is a temperature difference, heat is produced or absorbed depending on the direction of current and the variation of temperature. That means if you have a rod and there is a current flow through the rod, it will give us that there is a heat is produced or absorbed. Of course, depend on the direction of the current and also depend on the variation of the temperature generated. So, based on these three effect principles, we can create our device, which is the thermocouple. Okay, what's the idea that we created by using these three effect principles? Just let us say we expose a metal rod to the source of the fire. Atoms in the source of the fire will vibrate more than the atoms that very far from the source of the fire, as we mentioned before. So this leading to the electrons going from the hot end to the cold end, and the amount of electrons here becomes more in the cold end. So this movement of electrons will create a current movement, more electron in the negative and less in the positive side for this rod. So voltage, it is like pressure. When you measure voltage, mean measuring the difference between the 2 points. The same thing for high pressure. High pressure, that mean you will face certain high pressure comparing to the atmospheric pressure. This is our reference. Atmospheric pressure is known for us. So if we add more pressure above that atmospheric, that means I have high pressure. The same thing for the voltage. Just to talk the difference between 2 points, and it will give me a voltage difference between these 2 points. If we measure in the same point, there is no voltage at all. So the voltage here is reality a difference between 2 points. Okay, go to the thermocouple. If we expose two metals, the same metals, if we expose them to the same source of heating, This temperature will be generated now, and there is a current will go from the hot junction side to the cold one side. But the number of electrons that go into this one rod and the number of electrons that go into this rod are the same values. So in the end, this difference in the electrons will be the same, which is 0. The number are the same, and which is the difference between them is 0. So in the end, it will give me 0 millivolts. No voltage here, even though if there is a current is moved already. So we are here missing the idea of Pelter's effects of Seebeck effects here. Now let us say bring another material. Of course, because of the different material properties, the number of the electrons that went from the hot side to the cold side will be different number of electrons, and this different number of electrons will generate a difference in the voltage or potential between them. Of course, to measure the thermocouple relations between the number of voltage changes and it's the hot effects because of this junction, we need to give them some reference. So we need to return it back to the certain reference. For example, the freezing point of the water or the melting point of water. This reference, we can base on them, we can depend on them, our millivoltage changes based on this reference in the voltage and the temperature. Now let us see the video that talk about thermocouple and its advantage and disadvantage.
A thermocouple, or simply TC, is comprised of a couple of specific dissimilar wires joined together, forming the sensing point or junction. Based on physical characteristics called thermoelectric effect, when this junction is placed at different temperatures, different millivolt signals are generated, which can be interpreted as an indication of the temperature. In comparison with RTDs, thermocouples are self-powered and require no external excitation current source. Thermocouples are commonly used for furnaces, gas turbine combustion chambers, high-temperature exhaust ducts, etc. The main restriction of thermocouples is the accuracy, which doesn't make it the best solution for precise applications. Also, thermocouples need a reference measurement point called cold junction. The thermocouple junction is often exposed to extreme environments, while the cold junction is often mounted near the instrument location. Based on range of temperature measurement, sensitivity, and some other factors in each application, different types of thermocouples are available. For example, E, J, K, M, N, T, and so on. For instance, Type J is made up of iron constantan combination, with a range of -40 degrees Fahrenheit to positive 1,380 degrees Fahrenheit, and a sensitivity of about 27 microvolts per degree Fahrenheit. While Type K, chromal aluminal, is one of the most common general-purpose thermocouples with a sensitivity of approximately 22.8 microvolts per degree Fahrenheit. Type K is inexpensive, and a wide variety of probes are available in its -330 degree Fahrenheit to positive 2,460 degree Fahrenheit operating range. Since the functionality of thermocouples is based on thermoelectric effect in different types of conductors, when the location of a thermocouple is far from the measuring instrument, for example the electronic transmitter, the proper type of conductors should be used for extension purpose. Otherwise, the tiny signal generated by the thermocouple will be added with some error at the point where the thermocouple wires are connected to the extension wire.
Now, based on this thermocouple, if we connect this thermocouple, and because of their reduction in the accuracy, their accuracy is not that much, and its output voltage is macro, values, even though if it has very high ranges, different variating in the ranges, and some of them are very high, but still the accuracy here is a problem, and also the very small or tiny voltage differences here is a problem. Now, based on these problems, they came with this new device, which is also, you can say, it is a improved generation or improved version of the thermocouple. This type of device, we call it Thermopile. Now, let's just go to this video and we'll understand the idea of the Thermopile.
So the thermopile, if you see, it consists of many serially connected thermocouples. So why this is done? This is done for increasing the output of this thermoelectric sensor. If you see a single thermocouple, the output is in the order of the microvolts, so which is not sufficient. So for this purpose, many thermocouples are connected in series, and if you see, their hot and cold junctions are thermally connected in parallel. Here we can see this is the electrical diagram, so how they are connected. So the finally the output voltage is taken across this all the thermocouples. So here this is the thermocouple, so which is connected to the other thermocouple by a series connection. So they are electrically connected in series, but here you can see their hot junctions, they are connected in parallel. So this is one hot junction, this is other hot junction, this is one more hot junction. They are all connected in parallel, and these hot junctions are exposed to the temperature where the temperature need to be measured. So the equation of this thermopile is given by, so output voltage E equal to N into ST, where N is the number of thermocouples that are present in the thermopile, whereas T is the Seebeck coefficient of the thermocouple, and T1.
Seebeck effect that we talked about it now previously, it is the sensitivity of the thermocouples device with the temperature. That means how much the sensitivity of the change in the temperature that will produce this my voltage. The addition here in the thermopile, they add this number, which is N. If we talk about thermocouple, it will becomes 1. But if we say thermopile, is dependent on the number of the thermocouple that we joined it together. So if we join 3, that means 3. 3 multiply the type of these thermocouples that you added.
One is hot junction temperature and T2 is the cold junction temperature. And if you take that thermopile consists of only one thermocouple, then N becomes 1. Thermopiles are widely used in non-contact temperature measuring devices like IR thermometers and pyrometers. So there the radiation that is emitting by the object is measured, and that is converted to electronic signal. Here you can see this is the thermopile, so that is encapsulated in a metal housing, and there is a window. So a window will only allows the required radiation, and it suppresses the any other interferences. Here you can see through this window the radiation that is emitting by the hot object is allowed to pass on to the thermopile, and the thermopile absorbs that, and the temperature of the hot junction increases, and correspondingly the output EMF is increased. So here you can see there are 4 leads of the thermopile. 2 are corresponding to the thermopile and 2 are corresponding to the reference sensor, as we have discussed in thermocouple, so which requires cold junction compensation. So here similarly, as the output is not proportional to the absolute temperature, so reference sensor output need to be compensated. And this is the different configuration, so where the thermocouples are connected in star configuration. The thermopiles are designed to measure temperature from a distance by detecting objects infrared energy, because whenever any body is above absolute 0 degree Kelvin, it emits IR radiation, so that is proportional to the temperature of that hot object, and higher the temperature and higher the IR energy that is emitted. And interested IR range is 4 micrometer to 20 micrometer for temperature measuring applications. And a reference sensor is designed into the package as a reference for compensation, as we have discussed for thermopiles. And here we can see this is the gun type IR thermometer. So by pressing the trigger, so the IR radiation.
The video explained how can you use the thermopile together in order to sense the radiated heat energy by the radiation. He explained it already. The name, another name for this device that he explained it now, is called pyrometer. Pyrometer, which is also, we can say, a next generation for the thermopiles. So the original was thermocouple, then after that we create another one which is thermopile, then after that we create this pyrometer. Pyrometers are devices that measure temperature by sensing the heat radiated from a hot body through fixed lens, as we saw in the explanation, that focus the heat energy onto the thermopile. This is non-contact devices. Furnace temperature, for instance, are normally measured through the small hole in the furnace wall. Also, we need to take care for that the field of view for the pyrometer to work properly. This is the measured objects that emit the radiated energy or radiated high heating energy. They should focusing these radiated energy to certain lens in order to let it concentrated in this sensor, which is our pyrometer here. But if we missed the area of the focusing the energy for this object, we will lose the temperature sensing here. So we need to take care for this one. This one of the disadvantage of the pyrometer. And we sometimes we cannot say it's a disadvantage, but it's a disadvantage if we don't care for the distance, required distance to measure this radiated energy. So it's limited distance. So it's not that open in every distance, just it's limited. With limited distance in order to take a proper or correct measurement for the temperature using the pyrometer. Sometimes they call it IR or infrared gun. It is also the idea for pyrometers measurements. Sometimes it's not necessary to put the sensor under the couples of the thermocouples and under the focusing of the radiated energy or radiated heat energy and the connections of the thermopile. Sometimes we can also find detecting for the colors of the fire or the color of the energy. Based on the color also we can decide the degree of energy or degree of the heat, and we can decide based on that the degree of the temperature change. Now this is the pyrometer, which is measuring the temperature by the radiated heat energy, and we know that it is generation coming from the thermopile and which is originally created by the thermocouple. But we can also change the thermopile with another type of sensing element like color detecting energy because of the heat effects. Now let's go to the next type, which is last type for our devices here in these lectures, which is called the semiconductor elements. Semiconductor temperature sensor. That means we will use the semiconductor devices or the semiconductor pieces or electronics parts in order to measure the temperature by using them. It is one of the specification of the semiconductor properties of the semiconductor material, like the famous one, silicon. Now let us see this video. Let's talk about the semiconductor temperature sensor, and it shows the
voltage
advantage.
across a PN combination of semiconductors, like a diode junction or base emitter junction of regular transmitters, is a function of temperature. This technology is vastly used in electronic devices and IC technologies. Linear characteristic, small size, and low cost are advantages of this technology. But it should be noted that the limited range of around -40 degrees Fahrenheit to 248 degrees Fahrenheit makes it suitable for specific applications.
As mentioned, there are also advantage for semiconductor devices. In this, other than that mentioned in the videos, also another advantage for it is that the electronic can be integrated into the same die as the sensor given. Also high sensitivity. Also easy interface to the control system. This is another advantage, which is make a different digital output configuration possible by using this semiconductor. Semiconductor device also rigid and can take long life period. Also, it is not expensive. These are the advantages for using the semiconductor devices. So, the thermal time constant variate from 1 to 5 seconds. Also, even though it's still exposed to the internal dissipation that can be cause up to 0.5 degrees Celsius offset. So, because of these advantages of the semiconductor, they can be used extensively in many applications as a replacement for the mercury glass thermometer, which is the first device explored or invented for measuring the temperature. By the end of this device, we finished our explanation for the main or the common devices used for measuring the temperature. Now, this is the end of this video, and waiting for me for the next video, just we'll talk about small comparisons between these different type of devices. Thank you for watching this video and waiting for the next one. Assalamu alaikum.